In this instructional video, we're going to talk about applying systems of equations or system of equation word problems. So applying systems of equations, there are really things you can use these for in real life. So many applied problems involve more than one unknown quantity. Although some problems with two unknowns can be solved using just one variable, it is often easier to use two variables. So to solve a problem with two unknowns, we must write two equations that relate the unknown quantities. The system formed by the pair of equations can then be solved using the methods of this chapter we've been talking about. So here are the steps for solving word problems involving systems of equations. One, as always, read the problem carefully until you understand what is given and what is to be found. Two, assign variables to represent the unknown values. Using diagrams or tables needed, write down what each variable represents. Three, write a systems of equations that relates the unknown. Four, solve the system. Five, state the answer to the problem. Does it seem reasonable? And as always, check and make sure your answer makes sense. All right, so let's go ahead and run through several examples here, and hopefully this will carry you through the rest of what you need to do in the Math Excel homework or in class. Example one, Karen bought some large frames for $15 each and some small frames for $8 each at a closeout sale. If she bought 22 frames for $239, find how many of each type she bought. So in this example, I think I'll go ahead and let X equal the large frames. And I'm going to let Y equal the small frames. So always define some variables here. Now what we're trying to do is write two equations involving both X and Y. Now one I'm looking at here, I know she's got 22 frames altogether. So I'm going to go ahead and put my first equation over here as X plus Y equals 22. All right. Now notice also they talk about money in this one. How much does a large frame cost? How much does a small frame cost? And then we've got a total amount of money here. So the second equation, I'm going to deal with money. And I think from this first one, you'll be able to set up the second one as well. So would y'all agree that the large frames being $15 would be 15 times X? So in other words, if there was one large frame, $15, two, $30, three, $45, and so forth, plus 8 times the small frames, and the total for that would be $239. So you can actually use systems of equations in real life, and it will help you out. Now, to find out how many large frames and small frames, we have to solve the system. And do y'all want to be X haters or Y haters? I think I'm going to be an X hater here and multiply this first equation through by negative 15. Or you could have said negative 8 if you wanted to take out the Y's. I just took out the X's for the heck of it. All right, so I'm just going to sneak that right underneath here. I'm going to say negative 15X minus 15Y equals negative 15 times 22. Now, you may want to get your calculators for this. I end up with negative 330. So adding them together, my X's are now gone. So calculator may help you in this exercise. Negative 7Y, then, adding the Y's together, will be 239 minus 330. I'm getting negative 91, and I hope y'all are too. Divide both sides by negative 7. Y equals 13. So don't get too happy. I have a lot of students at this point go, I got it, I got Y, I got X, but they didn't answer the question. So we're going to put 13 back in here for the small frames. How do we get the large ones? Well, we have to take that 13 and either plug it in here or here. And you know which one I'm going to take because I'm always the lazy guy. The first one. X plus 13 would then equal 22. So to get the large frames, subtract 13 from both sides, and X would be 9. So there would be 9 large frames and 13 small frames. And I see a lot of students mix those two numbers up and not check, and then they miss it on the test. They put 13 large and 9, so they don't understand what they're doing. Now, to check this, how would you check it? Well, you would take the large frames, times $15, the small frames times $8, add them together, and you better get what? $239, and I do believe you will, and it will check. All right, so you can use these things in real life, and now let's see if you can set this one up. So after I read it, pause it and see if you can define some variables and set it up similar to that first example, and that's a great way to look at things here as you're going through these. All right, Hilton University Drama Club sold 311 tickets for a play. Student tickets cost 50 cents each, while non-student tickets cost $1.50. If total receipts were $385.50, find how many of each type were sold. All right, so again on this one, I might go ahead and let X, okay, you might want to pause here and I'll come back. Pause, try it yourself. All right, now you must have hit play, so I'm going to keep going. So I'm going to let X equal the student tickets and Y, of course, be the non-student tickets. So did you get these two equations for your system? Did you get X plus Y equals 311? And did you use the money fact that student tickets were 50 cents each? So I'm going to put as a decimal 50 cents plus $1.50 for non-student tickets equals how much money? $385.50. That would be your two systems of equations. And then what I would do on this one, if I were y'all, I would get rid of the decimals on the second equation to make this a little bit nicer. And to do that, all I have to do is really multiply by 10. Now, some students might think 100's better here, but 10's better because you have zeros on the end of all those decimals. So let's just rewrite this one. First equation we'll leave alone. X plus Y equals 311. The second equation, we're going to go ahead and put multiplying 10 through. It would give us 5X plus 15Y equals 3885, and all the decimals are gone. Now, do y'all want to be an X hater or Y hater here? I think I want to be an X hater and multiply this first equation by -5 to get rid of the X's. Now, of course, you could multiply the Y by -15 and get rid of them. So it's up to you. I mean, you'll get the same answers either way. So I'll bring this down like I did in the previous example, and we'll get -5X minus 5Y equals -1555. The X's will go out, leaving me with 10Y equals 2300. And dividing by 10Y, the non-student tickets will be 230. So you always want to identify what you're after, what you just solved for. You got 230 non-student tickets, and to get the student tickets, I wonder where I'm going to plug in that Y for, here or here. Yes, the easy one. So X plus 230 equals 311, and solving, X would be 81 student tickets. Now again, it will check. 81 times 0.50 would give you that one answer. 230 times $1.50 will add up to be $385.50. All right, third and last example here, and I'm just going to run through the steps and just kind of run through this one. Salaries for the same position can vary depending on the location. In 2006, the average of the salaries for the position of Accountant 1 in San Diego, California, and Salt Lake City, Utah, so this is the average of the two now, it's $41,175.50. The salary in San Diego, however, exceeded the salary in Salt Lake City by $3,697, so they want you to determine the salary for the Accountant 1 position in San Diego and in Salt Lake City. So again, step one, read the problem. We must find the salary of those positions in both Assigned variables, we'll let X be the accounting 1 position in San Diego and Y be the salary for the same position in Salt Lake City. Write a systems of equations. So here's the first one. Since the average of the two, X plus Y divided by 2 gives us 41,175.50, 41,175.50. Multiplying both sides by 2, again to get rid of the fractions, which we've done before, will give us this first equation, X plus Y equals 82,351. It says also the salary in San Diego exceeded the salary in Salt Lake City by $36.97. Therefore, this gives us a system of equations X minus Y equals $36.97. So you can see our systems are lining up well. And now, do you want to be an X hater or Y hater? Well, I think the Y's are going to drop right out there. And solving for X gives us $43,024. Plugging back in, Y will be $39,327. And then we got the answer there. So the position for accounting 1 in San Diego, 43,024. Salt Lake City, 39,327. Both pretty decent paying jobs there. And the answer will check. So solving systems of linear equations, go ahead and practice a ton in your homework now and get good. Bob Young, signing.